here we go. And so the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today, eventually, we're going to go on to section 4.5. But first of all, we have a question or two on section 3.7 from yesterday. So let me bring up the screen to do the graphing. And let's see here. Let's open that. Okay. So we have the inequality 7, things are not working good. 7x, there we go, minus 4y is greater than 12. Marisol, do you want me to use the find 2 points method or the slope intercept method?
So I used the find 2 points.
Okay.
And I got points 0, 0, and 3. And then my second set of points was 1 and 4. But when I went to submit it, I don't know if I did some arithmetic wrong or I got some weird points.
Okay. So you used x was 0 and you found y was 3. You used x was 1 and y was 4. Is that what you said?
Yes.
Okay, well, let's check that out here. Okay, so I'm going to look at the equation 7x minus 4y equals 12. If x is 0, I get 7 times 0 minus 4y equals 12, which means negative 4y equals 12. Divide both sides by negative 4 and y equals negative 3. Did you have negative 3 or 3?
Oh, I got 3.
Okay.
It should have been negative 3. Okay. That was my problem.
Well, let's keep going. If x is 1, we get 7 times 1 minus 4y, equals 12. 7 minus 4y equals 12. Subtract 7, negative 4y equals 5. Divide by negative 4, y equals negative 5/4. Okay, so it looks like your points weren't quite right on that. Okay, so 0, negative 3 would be here. 1, negative 5/4 would be right about there. Okay, since this is not equal, since it's just greater than, we're going to have a dotted line. So let me make the dotted line going through those points. And then let's see, let's pick a test point. Let's try 0, 0. If x is 0 and y is 0, is the inequality correct? 7 times 0 minus 4 times 0 greater than 12. 0 minus 0 greater than 12, 0 greater than 12, no. So this is not the correct side, so this is the correct side. You all right with that?
Yeah, I ended up figuring out that that was not true, but just my points were off.
Yeah. You figured out that what was not true using 0, 0?
Yeah.
Yeah. Okay, we good to go on that?
Yep, thank you.
You betcha. Any other questions from anyone before we go on to the new stuff? All righty, and let's proceed. And let's see here. I am going to go to the next page. Now, what we're looking at today is graphing a system of inequalities, all right? So we're going to graph more than one inequality on the same graph. And when we do, the solution will be where the 2 individual solutions from each inequality overlap. Okay, so let's take a look at that. And if I lost you there, don't panic. This is what we're doing today. Okay, let's see here. We've got 2x plus y greater than or equal to 3. Okay. And let me find my mouse here. Where are you? Ah, there you are. And x minus 2y less than or equal to -1. Now, I can use the slope-intercept method. I can use the 2 points method. I'm going to use the 2 points method for this first one. And then if somebody wants me to come back and do it using slope-intercept, I'll be happy to. Doesn't matter to me which method you use. Okay. So let's go back here and let's take a look at the black inequality. Okay. So I'm going to find 2 ordered pairs. Let's see, I think I'll let x equal 0. So if x is 0, oh, and I'm going to consider the equation 2x plus y equals 3, okay? So I'm going to find my points using the equals part. If x is 0, 2 times 0 plus y equals 3, 0 plus y equals 3, y equals 3. So 0, 3 is a point on the line 2x plus y equals 3. Let's find another point. How about if x is 1? If x is 1, we get 2 times 1 plus y equals 3. 2 plus y equals 3. Subtract 2 from both sides, y equals 1. So my 2 ordered pairs for the black inequality are 0, 3, and 1, 1. Now, as I look at the inequality, I see that it includes the equals. So that means that my line passing through those points is going to be a solid line. Let's see here, using a slope, I can do this. Let's make that. Okay. Now, I need to determine, are we on the upside of the line or the downside of the line? Since I didn't put it in slope-intercept form, it's not as obvious. I'm going to choose a test point. I'll choose the origin. So let's see. If I plug 0, 0 into the inequality, so I'm not using the equation now, I'm using the inequality, 2 times 0 plus 0 greater than or equal to 3. 0 is not greater than or equal to 3. So the test point failed, which means we're on the upside of the line. Okay. So the solution to the first inequality is in black there. And this is basically what you did yesterday. All right. But now we have a second inequality, the red one. So let's see here. Again, we'll make a table. And we're going to consider the equation x minus 2y equals -1. I'll start with x is 0. If x is 0, I get 0 minus 2y equals -1. -2y equals -1. Divide by -2y equals 1/2. All right. Let's see. How about if x is 1? And again, I don't have to use 0 and 1 all the time. I'm just doing that because it works. Okay. If x is 1, 1 minus 2y equals -1. Subtract 1 from both sides. -2y equals -2. Divide by -2 and y equals 1. All right. So for the red inequality, I have the points 0, 1/2, which is right there, and 1, 1, which is right there. I see that it includes the equal sign, so the line, the red line, is going to be solid. And let's see here. I could do a more accurate job if I was using the Webassign stuff, which I will do here in a little bit. Okay. It's hard to line up the ruler and make it, yeah, quit making excuses. Okay. Again, let's use 0, 0 as a test point. So now I'm going to plug that into here. 0 minus 2 times 0 less than or equal to -1. 0 less than or equal to -1. That is true. So for the red, we are below. Now, where is the solution? The solution is where the red and the black overlap. Let's do that in green. And let me move this out of the way. I don't know if that helps or not. So can you see what's going on there? It would include this part of the black line. And let's see here, this part of the red line. That doesn't really show up very well there. But so it would be, and that goes on out forever, so to speak. Any questions about that example?
Yes, I have a question. Isn't 0 greater than -1?
Yes.
So,
oh,
because you did for the second one that the test point was.
Yes, yes. My bad. My bad. Yes. 0 is less than negative.
Okay.
Is not true, is it? Good job. Oh, that just that changes everything. Okay. Thank you. And yet it's Tuesday, but it seems like a Monday to me. So
it's the beginning of the week.
Thank you. Thank you. Yes. Well, I made it through a day and a minute before I made my first mistake. Okay, at least that anybody knows about. So this 0 is not less than or equal to -1. Thank you. So that is false. So that means, where are we going? We're going
above.
Above. Thank you very much. I'm taking the rest of the day off. You teach the class. I'm happy with that. Darn. Okay. So now we have this. So there's our solution. Yeah, sorry about that. Honestly, and this is, well, it's going to sound like an excuse. I like doing slope intercept forms so much better. And so when I do it this way, in my mind, I'm still saying, oh, just, and I know some of you, it's been a long time since you've done that, since the whole idea of y equals mx plus b is foreign to you. It needs to be right there in the brain, but we'll get there. But that method, if you're able to do it, is so much quicker. But anyway, enough whining on my part. All right. Shall we do another one to see if I can redeem myself? There's always hope.
Sure, why not?
All right. So let's go to another example. And let's see here. Let's go back and make this black. Our first inequality. Let's see. X plus y greater than 2. Tell you what, I'm just going to go ahead and graph that whole thing, and then we'll go back and put the second one in. Maybe if I have to do less switching around, I'll make less mistakes. There's always hope. Okay. I'm going to use the point method again. If at any time, like I say, you want me to use slope intercept, say so, and I'm happy to do so. All right. So if x is 0, and I'm going to use the equation, x plus y equals 2. If x is 0, y is 2. So 0, 2 is right there. And let's see, if x is 1.
So does it matter if you, for x, you could use any number, or does it just have to be 0 and 1?
You could use any number you want, but you have to live with your choices. So be careful. You know, don't pick something like 17/3 or the square root of pi, and don't pick something huge, because then if you have to plot it and it's way out there in space, your graph is going to be difficult to create. But yeah, you don't have to. In fact, yesterday, I think I used the intercepts. Sure. I'm just picking something small and that I can see is going to come out nicely. But yeah, you could pick something else. It doesn't have to be 0 and 1.
Yeah, that's what I was like wondering. Thank you.
Yeah. Nope, doesn't have to be. All right, so then we get y equals 1. So we've got 0, 2, and 1, 1. Okay. Now, this does not include the equals. So we're going to have a dotted line. What am I actually doing here? I'm just using the slope to get extra points to line up. Okay. And let's use 0, 0 as a test point again. 0 plus 0 greater than 2, 0 is greater than 2. Because of my mistake before, I'm going to be careful here. 0 is not greater than 2. So 0, 0 is not a test point that is valid. So we're above it. So far, so good?
Looks about right to me.
Thank you. I wanted some confirmation. I'm feeling bad now. All right. Let's see here. X minus y less than -2. X minus y less than -2. So now I'm going to look at x minus y equals 2 to find my ordered pairs. Tell you what, we'll use something besides 0 and 1 just to show you it doesn't matter. If x is 3, I'd get 3 minus y equals 2, subtract 3, negative y equals -1, divide by -1, y equals 1. And how about 4? If x is 4, 4 minus y equals 2, subtract 4, negative y equals -2, divide by -1, y equals 2. So 3, 1, 4, 2. Again, we don't have equal, so we don't have a solid line, we have a dotted line. Okay. And let's use 0, 0 as a test point. 0 is not less than -2. I learned something. So 0, 0 is not valid. So we aren't going to go there. We're going to go on the other side. Of course, having said that, now I probably messed up something else. So let's see here. Such confidence I have.
So for the y, is it -2 because you just put 2?
Say that again.
For the y is because how you divided -2. Oh yeah, it is. It's +2, isn't it? Since you divided 2.
You're talking about right here?
Yeah.
Yes. Yes, that's right there.
Oh, okay. Okay. I was lost. Sorry.
Yeah, no, that's okay. Hey, see, I make one mistake and my credibility's shot.
So
that's
the
okay.
y, you divided it by 1 because it was a negative y?
Oh, here?
Yes.
Yes. Yes, because, okay, so if you have -y equals -2, to get y by itself, you would divide by the -1 coefficient.
Okay.
-y is like -1y. There's an implied 1. Okay? All right. Let's see. I think I was getting ready to highlight the solution, which would be right over here. Now, in this case, both the boundaries are dotted lines. So it would not include this piece or that piece. Those are dotted. They're establishing that's the fence, but it's the neighbor's fence. Okay with that?
Yeah.
Questions there? Anything? Okay. Let's go on and take a look at another one. We good to go on?
So you don't go over the dotted line. It's just you just keep that little triangle where they meet each other.
Right, because the dotted line is the boundary, but it's not part of the solution. If it was a solid line, that would mean it's included. Okay, but a dotted line says, well, there's a boundary, but we don't own the boundary. We don't include it.
Okay.
Does that make any
So
sense?
the boundary is only where the solid line's at?
That's included. The boundary that's included is only when it's a solid line. Yeah. Does that make sense?
Kind of. Yeah.
Tell you what, let's do this. Let's play with this problem a little bit, okay? Let's say that it was actually this, okay? So then, let's see, that was the black line. This line right here then would be solid, okay? And then the solution would be, it would include this line right there and everything that's intersecting, but it wouldn't include this piece. Does that make sense? So everything on this line segment and in this triangle is a solution, but this piece right here is not a solution. The line is solid if there's an equal sign. The line is dotted if there is not an equal sign. And if it's dotted, it establishes the boundary, but it's not part of the answer.
So anything before the dotted line is the solution?
Over here?
Yeah.
Yes.
All
It
right.
includes all of this, and it also includes this solid line. Okay. Think of it this way. Okay. There's a property where there's 4 neighbors. Okay. We got 1, 2, 3, and 4. So, can you see the number 4, or is it covered up by all of our pictures?
It's fine.
I can see it.
Okay, because then apparently what I see is not what you see. If I move this around, does it move it around for you?
No.
I'm moving around the picture with everybody's. Okay, all right. So this person number 4 owns this fence down here. Okay, but they don't own this piece of fence. That belongs to neighbor number 1. So if I said, well, what property does number 4 own? You'd say, oh, they own all of this, and this is their fence. Oh, but this piece here is not their fence. There's a fence there, but it belongs to the neighbor. It establishes the boundary, but it's not included. Does that make any sense?
Yeah.
Okay, all right. So let's go on to another example. And then I want to do a couple in Webassign just to make sure people are clear on what's going on there.
For this next example, could you use a slope intercept?
Absolutely. Absolutely.
Thank you.
Let's see here. 3x plus 2y minus 12 greater than or equal to 0. Okay, so to put this in slope intercept form, I'm going to add 12 to both sides, which gives us 3x plus 2y greater than or equal to 12. Then I'm going to subtract 3x from both sides, 2y greater than or equal to negative 3x plus 12. Why am I putting the x in front of the constant? Because I'm looking for y equals mx plus b. I'm going to divide each term on both sides of the equation by 2. So there is the inequality in slope intercept form. So the slope is negative 3/2, and the y-intercept is 6. Any questions before I go on? So now I'm going to graph the black inequality. So the y-intercept is 6. The slope is negative 3/2. So going from left to right, I go down 3 and over 2, down 3 and over 2. And I don't need to do this 1,000 times, but the more I do it, the more easier it is to line up my points with the ruler. Now, since the original inequality included greater than or equal to, we are going to include a solid line passing through those points, okay? Now, having solved for y, all I have to do now is say, let's look at the direction of the inequality. It says y is greater than or equal to. Well, if y is greater than the line, where is y more than where the line is? It's above the line. Okay. Any questions so far?
Could you do it the other way? I'm like better.
Yeah, okay, tell you what, let's do this. Let me finish the whole problem this way, and then we'll go back and we'll do the whole problem the other way, okay?
Thank you.
You bet.
Seems like a good bet.
All righty. Whatever it takes to get you there. If I have to
Mr. Mayo, quick question.
Yes.
On the test, should we expect to see both forms? We know both methods, or whichever one is easier for us to solve?
The directions say graph the solutions.
Right, but we can use either method, is that right? Or are you going to request that we use a certain one or the other, or both?
Two things I want to say. You should know how to do them both, but the test will not specify, do it this way, do it that way. You can use it either way. Okay?
Okay, thank you.
Uh-huh. See, she's already thinking about the test and I'm just thinking about lunch. All right, let's see here. Let me find where I got that. Here's the other one. Okay. X less than -2 plus y. All right. I'm going to add 2 to both sides. So x plus 2 is less than y. Now, I'm not going to divide or multiply by a negative number and switch the direction of the sign. I'm just going to pick that whole thing up and change the viewpoint. For instance, okay, let's see. Who was it that asked me to do it this way? Was it Abel?
Yes.
Okay, Abel, I don't know how old you are, but I would venture to say that you are younger than me. Would that be a fair bet?
I'd assume so.
So Abel is younger than Ben. Is this also true? Ben is older than Abel.
Yes.
All we did was change the viewpoint. The first comparison was all about Abel. The second comparison was all about Ben. All right, this says x plus 2 is less than y, therefore y is greater than x plus 2. Do you see how I got that? It's the same thing?
Yes.
Okay. So slope-intercept form, the slope is 1 because there's an implied 1 in front of x, and the y-intercept is 2. Okay? So y-intercept is 2, the slope is 1, so we're going to go up 1 over 1, up 1 over 1, up 1 over 1. This does not include the equal sign, so it's just a dotted line. Okay, it says y is greater than, so we're talking above. So our solution would be, oh, it's not there, drew it in the wrong place. Our solution would be here, where the red and the black overlap. And again, it would include this piece, but not that piece, because this piece was solid, this piece was not. Okay?
All right.
We're going to go on and do this exact same problem again using the find the points method. So again, we've got 3x plus 2y minus 12 greater than or equal to 0. And I'm going to go ahead and put that other one up there. X less than negative 2 plus y. Okay. So I'm going to consider the equation 3x plus 2y minus 12 equals 0. I don't remember who it was that asked me to do it this way. Do you have a particular value you want me to use for x?
No.
Okay. How about 0?
Okay.
So then we get 3 times 0 plus 2y minus 12 equals 0. 0 plus 2y minus 12 equals 0. 2y minus 12 equals 0. Add 12 to both sides. 2y equals 12. Divide by 2, y equals 6. Okay. Any questions there?
No.
Let's pick another value of x. How about 2? If x is 2, 3 times 2 plus 2y minus 12 equals 0. 6 plus 2y minus 12 equals 0. 2y minus 6 equals 0. Where did I get the minus 6 combining the 6 and the minus 12? Add 6 to both sides. 2y equals 6. Divide by 2, y equals 3. So 2, 3. Okay. We see that it's greater than or equal to. So we're going to draw a solid line. We'll use 0, 0 as a test point. So I'm going to put 0, 0 into the original inequality. We get 0 plus 0 minus 12 greater than or equal to 0, minus 12 greater than or equal to 0. Negative 12 is not greater, so it's not the origin. So it's over here. Okay. Using the red inequality, we'll look at the equation equivalent. And then let's see here. Tell you what, let's use the same numbers. Let's use 0 and 2 for x and x both times. Okay, if x is 0, we get 0 equals negative 2 plus y. Add 2 to both sides, 2 equals y. So 0, 2. If x is 2, we get 2 equals negative 2 plus y. Add 2 to both sides, and y equals 4. So 0, 2, 2, 4. And that does not include equals. So that's going to be a dotted line. Okay, and I'll use 0, 0 again in that. Is 0 less than negative 2? No, it's not. So we're not over here, we're over there. So our solution is up there. So let's compare that. Let's see if we got the right. Looks like it. Different colors, but I guess I could have gone ahead and, here, let's make the solution green. Okay, so you get the same answer. All right. Okay, what I want to do now is I want to go to Webassign. So I'm going to close that up and open this up. And let's see here. Let's make sure that you can see. So can everybody see the Webassign screen here?
Yes.
All right. Now, I'm not sure why, but yesterday I showed people on the video and during the lesson how to graph in Webassign. And I got a bunch of questions from students that were not doing it the way I showed them. So I don't know if you just didn't follow my directions, or maybe the videos from the Webassign people are showing it differently. I don't know, but I want to go over it again and reinforce the process, because I know some of you are not doing it this way. And it took me a while to figure out how you have to do it to get it to work right. Okay. So now, let's here, let me get things set up the way I need them. Okay. These both happen to be in slope intercept or form already, okay? So because of that, I'm gonna take advantage of that, because that'll save me some time. And really, what I'm trying to show you here is not so much as how to get the answer algebraically, but rather how to graph it once you have the answers, okay? So I'm going to go back to my whiteboard screen. The first one, the y greater than y greater than 2x minus 7, the slope, let's make that in black. The slope would be 2, and the y-intercept would be -7, okay? For the second inequality, the slope would be -1, and the y-intercept would be -1. Notice that the first one does not include equals, and the second one does, okay? So let's focus on the first inequality. It has a y-intercept of -7 and a slope of 2. So now I'm going to go back to my Webassign board. Okay, so the first thing I do, I am not going to use this little square with the dot. Okay, that's your first mistake. If you use those, it doesn't work out nicely. Sometimes you get away with it, but not always. I'm going to use this box right here, and I want to use the one that is the line, not the ray, not the line segment, but that. So I click on that until it turns blue. All right. Now, the y-intercept was -7. So I'm going to go down here and click on 0, -7. The slope is up 2 over 1. So I'm going to go up 1, 2, and over 1. Now notice something. My scale, each of those squares is 2, isn't it? Okay. Now, do I want a solid line or a dotted line? I want a dotted line. So I'm going to come over here, or dashed line, I guess. So there's my first graph. Now, I'm not going to shade either side of it yet, okay? Any questions about how I got that dashed line there? All right, let's go to the second one. So I'm going to go back here. And what was important here was that the y-intercept was -1, the slope was -1, and it does include equals. Okay. So again, I click on this until it turns blue. The y-intercept is -1, and the slope is -1. So I'm going to go down 1 over 1. Okay, and that's solid. That line should be solid. All right. Now I have 4 different regions. Where is the region that they both overlap? Well, the first one, the y greater than 2x minus 7, which was the dotted line, it says y is greater. So for that one, I would be over here, okay? But the y greater than or equal to negative x minus 1, it said y is greater than or equal to. So that would be above, which would be here and here, okay? So one of them has it in these two, one of them has it in those two. So where they overlap would be right here. Did everybody follow that?
Yeah.
The first one would be both of those. The second one would be both of those. Where do they overlap? This one here. And then let's submit the answer and see what happens. And there you have it. Now, notice I used 2 points to form each line. I did not use this button. I used this button, okay? And I think, I don't know if this is gonna make sense to you, but this is why I think it doesn't work if you use this button. This button establishes a specific point. When you use this button, it just plots points to find out where the line is. But when I turn this line into a dotted line, these points, they aren't really part of the graph. They're just establishing where the line is. And I don't know if this makes sense, but if you put a point where it's supposed to be a dotted line, you're putting a point where it shouldn't be there. And the only way you can do that is to use this button, not that one. Now, in the case of where it's a solid line, I could have gotten away with it. But let's not focus on what we can get away with. Let's focus on doing it right in the first place. So you've got to use this one to graph this situation. All right. Any questions about that? Let's do this. Let's see here. Let's do a different one where they're not in slope intercept form. And this one we'll use the points method. Okay. So number 7, let me get that written down here on my whiteboard. 3x plus y less than or equal to 6 and 4x minus y greater than or equal to negative 6. Okay. So I'm going to
Mr. Mayo.
Yes.
So going back to that Webassign, I noticed that some of the numbers are notated red. Is there a certain reason why they're red?
Yeah. Okay. That's a good question. So not everybody has the same homework problems, and not everybody's going to have the same test questions. They're going to be similar, but the numbers in red, that's what's going to be different. So I could look at 5 different people's homework problem, this number set or whatever that is. Here, let's go back to, hang on here. So these 2 numbers that are in red here, the 6 and the negative 6, that happens to be on this one. One of you might have 7 and negative 7. One of you might have 10 and negative 10 or 12 and 3. Those are the parts that are different between different students, okay? So the process is the same, but you're gonna have different numbers. All righty?
All righty, thank you.
You're welcome. Okay. So let's go back to the whiteboard. And I'm going to look at the equation 3x plus y equals 6. I'm going to find some ordered pairs. Let's see here. If x is 0, I've got 3 times 0 plus 4 equals 6. Wait, it's not plus 4 plus y equals 6. My bad. So I've got y equals 6. Let's use 2. 3 times 2 plus y equals 6. 6 plus y equals 6. Subtract 6, y equals 0. So I've got 0, 6, and 2, 0. Okay. Now, let's see, 0, 6, and 2, 0. this is where things are going to get a little bit tricky in me going back and forth between different boards. If I were to do a rough sketch of that graph, I'd have a point at 0, 6 and at 2, 0, and it'd have a solid line going through those, right? What I'm trying to show you is that 0, 0 is not on that line. But if I put in 0, 0 into the inequality, I get 3 times 0 plus 0 less than or equal to 6. Is 0 less than or equal to 6? Yes. So that means that we're over there. Okay? Did you follow that?
Yes.
So I'm going to use the point 0, 6 and 2, 0. I'm going to draw a solid line and I'm going to graph below it. So now I'm going to go back to my Webassign screen. And I'm going to go 0, 6, 2, 0. It's a solid line, and I'm going to fill below it. Okay? So that's the black inequality, or the top one on Webassign. And again, I'm going to point out, I mentioned this yesterday, but if you get points that are hard to plot, you can come in here and put in their exact values and it'll fix it over here. Okay? So now let's go back here and look at the red inequality, which would be like this equation. And let's see here. I'll use x is 0. 4 times 0 minus y equals -6. Negative y is -6. Divide by -1, y is 6. 0, 6. Oh, interesting. For a minute there, I thought, did I mess up somewhere? Huh? Okay, and let's go ahead and use 2 again. So I get 4 times 2 minus y equals -6. 8 minus y equals -6. Subtract 8, subtract 8. Negative y equals -14. Divide by -1, y equals 14. Fortunately, my graph has a scale where each square is 2, so I can plot 214. If you get points that you can't put on the graph, then choose a different point, okay? All right, let's see. If I were to graph that 0, 6, 2, 14, again, I think that it'd be safe to say 0, 0 is not on the graph. So, but if I put 0, 0 in here, I get that. Is 0 greater than or equal to -6?
Yes.
So this part is good. So now I'm going to plot a graph that goes through 0, 6 and 214. It's a solid line because it includes the equals. And I'm going to shade below it. Okay. So make that blue. 0, 6, which is right there. 2, 14, which is right there. It's a solid line. Okay, now recall that we, for the first one, the 3x plus y, it was shaded below this line, okay? So there and there. Now, for this one, it's shaded here and here. So the intersection would be down there. Does that make sense?
Yeah.
All right, so let's submit it and see what's going on there. And there you go. Oops. I guess after I clicked it, it changed things, but anyway, there's the solution. All right with that?
Mm-hmm.
Okay, well, it's time to go. Again, I will be back this afternoon at 1:15. Should you care to join me then? Anyway, I will put this up on YouTube later this afternoon, and have a great rest of the day.
Thank you.
Thank you. You too.
Thank you. You too.
Thanks,
You're
you too.
welcome.
Have a good day.
You too.